Good day, everyone. My name is Zolani Mdleleni, and this is my P2 project presentation. Right in front of me is the title of my project, which is Solar Power System. Right. Okay, here is the content of this presentation, which is the list of the things that I'm going to cover on this presentation. The first one is going to be the introduction, and then followed by the background of the project, and then it's going to be the components and their use that I used in the project, and then it's going to be the procedures carried during the project, then it's going to be the results, lastly it's going to be the conclusion of the project. Right. Introduction. Okay, this project is about supplying source of power or source of light at an off-grid area, which is the Titis Bay Beach, with the use of a solar power system. The background. Okay, the abstraction of this project is to supply paramedics with source of power or source of light at a 4-day event that happened in the Titis Bay Beach. Since the area has no source of power or light, I had to come up with a project to supply the paramedics on duty in the event, since it's a 4-day event. So incidents and injuries happen, so they had to work there, and then they needed power or light so that they can do their duties effectively. Right. Okay, right here is the components and their use. This is the list of the main components of my project. The first one is going to be the batteries, followed by the solar panel, PV charge controller, it's going to be the inverter, and then it's going to be the battery load sensor. As time goes by, I'm going to explain what does each component do or their function on this project. So bear with me. Right here are the main guys: the source of power, the solar panel, and the battery. So these two work hand in hand. Depends the time of the day, because this one is more useful during the evening, and this one is more useful during the day. Since this one works with sunshine or sun rays, the solar panel, its function is to supply power to the components and charge the battery at the same time. So during the day, this solar panel charges the battery and then also supplies power to the components. During the evening, this guy is pretty much useless because there's no sunshine, so the battery is the main guy that is working or supplying power to the rest of the components. So this one works in the evening. All right, up next is the PV charge controller, the inverter, and then the battery load sensor. Okay, this guy is the protection device for the battery. As the solar panel charges the battery during the day, it doesn't know whether the battery is fully charged or it's slow. It just charges. Where there's sunshine, the solar panel charges the battery. But this guy protects the battery to not overcharge. So when the battery is fully charged or it reaches a certain amount of voltage, this guy opens the circuit between the solar panel and the battery so that it doesn't charge. And then when the battery is being used and reaches a certain low voltage, this guy kicks in, closes the circuit between the solar panel and the battery so that the battery can be charged by the solar panel. So this guy right here is the guy that allows the components to be useful or to be able to use the power that is supplied by this system. This is the inverter. The inverter converts the DC power into AC power. Since most of the components use AC AC voltage, so this guy converts that DC that DC supplied by the solar panel or by the battery, converts that into AC, then it distributes to the rest of the components. Okay, right here, this is also a protective equipment. This guy detects when there's an overload, and as you can see, there's a fuse there. So you know where there's fuse, there's protection. So this guy protects in case there's an overload, so that it doesn't damage the source of power, which is the battery or the other components in the system. Okay, right here is the front and the back of my component board. So let me just give you a closer look. If you want to see clearly, you can just pause and zoom, and also check the back of the component board. Okay, right here I'm just showing you how I mounted my components on the board, and then this is the back, which you can see the connection, how I connected each component to what component. This is the back of the board and this is the front of the board, and you can see how I mounted the components and how I connected them. Right, up next is the procedures carried, so that you know how in case you want to do this project as well, you can know what to do and how to do it. Okay, the first one is making the component board. The component board is made of wood, so I had to drill and grind to open holes in the board, so that I can mount my components, and also able to put the wires or the cables that I used in a good way. So the first thing is to open holes on the component board so that we can put the components and mount them easily. And then up next is connecting and mounting the components, as I said before. The holes, we have to mount the components, and then at the back, so that your project is neat and clean, I did the connection at the back of the board, and then in front you can just see the components, and at the back is just the connection of the components. Yes, and then is the component labeling, because I was in the event, so people are curious to know about electricity or engineering, on how or what is what and how does what looks like. So I did some labeling, so that if a person passes through my project, they can see that this component is called this and all that. And then testing the project. I had to test the project before going to the main event. So before going to the event with the project, I had to test it to see if it works properly, because I don't want to go to the event and then I get there, the project is not working. So I did the testing before going to the event. Okay, and the results, the project was very successful. It was able to do the duties that it was meant to do, or it was expected to do. And then also the community benefit. As I was in the beach, it was an event, so it was full of people. The people I camped with around, they were also able to charge their phones using my project, because there is an AC power that is converted by the inverter from the DC to the AC. So they were able to charge their phones during the day and night. So they were very happy, so they benefited a lot about it. And also I obtained a certificate that I participated in this project, or built this project. And then the conclusion. The conclusion was that the project was very successful, and then also the people around, I was able to teach them about electricity, because some people are clueless about a lot of easy stuff or basic stuff of electricity, and also how to save power in their homes or in their apartments. So I was also able to teach people or interact with people about my source of career, or my line of career. Right, any questions?